So I'm going to stamp the foldable and then I'm going to stamp the mixed practice. Both of these will go in your spiral. We're about to end the unit here. And then you have a practice worksheet that goes with this.
We have a test
Coming up, yeah. Friday.
this Friday.
Yep.
I thought it was next Friday.
Okay. So what they're trying to get you to see here is I'm just going to underline HIJ and I'm going to highlight that because if I trace these letters and I go from H, I to J, I need you to recognize that that's representing, that's representing the whole angle. So I'm going from, if this is the biggest part, I'm going to do an arc from H to, like arrow to arrow, to indicate the whole angle, the biggest part. All right, so I'm just labeling the HIJ represents the whole angle. And what we have, because K is in the interior here, and we draw this ray going from the shared vertex I to K, we now have created adjacent angles. So I'm just going to number, first I'm going to name the angles. So if I'm talking about the first part, the first adjacent angle, I'm just going to do a singular arc here. I'm going to put the number 1. It's adjacent to KIJ, so I'm going to do a double arc and put a 2. I don't want to have the same marking because that would be saying it's congruent, and they're not. They're just adjacent. Okay? So whenever I see the whole, or whenever I see adjacent angles, to do the angle addition postulate, you're basically doing part, just like with the segment addition, part plus part equals the whole angle. Well, I can name the parts using 3 letters. So I can say angle HIK plus the angle KIJ equals the whole angle, which was the HIJ. And I ran out of room. Or I can just use our numbers here. Angle 1 plus angle 2 equals, and my whole angle is going to be, I'm going to number that 3, equals the whole angle, which is the third angle. Okay, that's just making you recognize the parts. You have to be able to see, is it a small part? Because like some people looked at, we got a small part. Another way I can label it is I have a small, sorry, I'm going to fix this. I have a small angle plus another small angle makes the big angle. Okay. So understand this makeup because we're going to use adding the parts to find our measures or to find our missing variable. So if you're giving a diagram and some information like what the angle equals or represents, you need to label it on the diagram. Like on this first part, it says angle. The measure of angle AOC is 70. So if I look A to O to see what does this represent? The whole angle. Okay, A to O to C is the whole angle. So I'm doing the arc from arrow to arrow, A to C, and outside the arc, we're putting 70. So the AOC is our whole angle. I'm just making sure you know what that part represents. Label it on the diagram. Then if you go here, it says the measure of AOB is half the 2x plus 20. So if I'm just looking at A to O to B, in this part here, I'm putting that expression, 1/2 parentheses 2x plus 20. Then they tell me BOC is x. So if I go from B to O to C, in this angle here, I'm putting the variable x. Get this labeled because this is where I'm checking for your understanding. This is part of the work I need to see, okay? So what we are showing here, hopefully you see it, is that you have a part plus another part equals the whole angle. So you're going to have to write the equations. So the first part we have the AOB, that's 1/2 2x plus 20. I'm going to add that to the BOC, which was just my x, and that is going to equal the whole angle, which was 70. So the next thing I'm going to check is the equation. You have it set up correctly. All right, we need to solve this, so we need to distribute the half to each term. This is going to be x plus 10 plus our x equals 70. Now we're just going to combine like terms. I'll put 2x. That should have been x, sorry. We're going to combine our like terms here. This is going to give me a total of 2x plus 10 equals 70, which really 2x is equal to 60. X is 30. So in this first blank right here, we're putting the 30. Okay? All right, now they want us to find the measure of BOC. Well, BOC was the x, so that is 30. Work smarter, not harder. If I know this small part is 30 and the whole angle was 70, what is this remaining BOC? 40. We're done. Okay? All right, so that's using the angle addition postulate. Add the parts up to make it equal the whole segment. All right, we have that one down? Okay, so the second tab is our bisector. Okay, so the key word is you got to understand what a bisector does. It's a ray that divides, I just highlight the key information, into two congruent angles. It says if ray AZ is an angle bisector of the whole angle WXY, name the two congruent angles that are formed. So first I'm just going to highlight the bisector. XZ, that's what's doing the cutting of the whole angle. The whole angle is our WXY. So to show bisectors, okay, since this is the bisector, and to show it on a diagram, you must see arcs to indicate a bisector. Meaning, I need to see a curve going from W to Z here, and I need to see that same curve going from Z to Y to show the two congruent parts. Okay? So we want to name, it says name the two congruent angles. The angle WXZ will be congruent to the angle ZXY. That right here, I'm just going to add a note, guys. This is showing part is equal to part. That's when you have the two parts. You need to add this to your notes because sometimes you're going to have to compare the part to the whole angle. So if I'm comparing this small part to the whole angle, okay, then you would have to double angle WXZ, whatever its measure is, to equal the whole angle WXY. So another relationship that you need to make sure you recognize is sometimes you have to double the part to equal the whole. It depends on what you have. Do you have two parts or do you have a part and a whole? Okay. All right, so on this example, to the right here, it tells us FG bisects the angle. So if FG bisects, then you have to add the arcs to the diagram to show it's a bisector. Okay, you cannot just assume, all right? We're going to see one in our mixed practice is not drawn to scale. So now, this first thing they tell us is the measure of G, F, H. Okay, so if I go from G to F to H, that is the 1/2 times the sum or the difference of 10x minus 20. So inside here, I'm doing 1/2 parentheses 10x minus 20. Okay. Then right here it says the measure EFG is 3x plus 10. Oh, 25, excuse me. So I go from EFG. All right, so in here, 3x plus 25. So when I look at this, do I have two parts or do I have a part and a whole? Two parts. And what do I know about these two parts? What's their relationship? Huh, they're congruent, yes. So what we have is, because our part equals our part, then all I have to do is write 3x plus 25 is equal to the 1/2 10x minus 20. So check that you label, then check that you write your equation to set it up. All right, so we just need to simplify this by distributing the 1/2 first. That's going to give me 5x minus 10. Start with your smallest variable. Eliminate that. So isolate the variable. So we get 25 equals 2x minus 10. Isolate the x term. Add the 10. We get 35 equals 2x. Sorry. And now take half of that. Our x is 17.5. All right, now they want to find the measure of angle GFH, okay? So I got to plug this value into the expression. I'm just going to break it down here. So we're just going to do substitution. We're going to do 1/2 of 10 times the 17.5, which was our x, then minus 20. So we're doing 1/2 basically of 155. What's half of 155? Okay, 77.5. All right, so we're going to work smarter, not harder. Because I know these two parts are equal, if I know this is 77.5, then over here, EFG is also 77.5. And that would let us know that the whole angle, 155, which is double those, okay? And if this piece on this side is 155.
You put the wrong one. EFH is
I did EFH. It's over here. I just made an arc from E to H. It's 155. Okay, if this is 155, then how am I going to get to this missing piece? It's not a right angle. That's why I did that. If this half, this side, not half, but if this right side is a total of 155, how do I get to this side? It's not bisected. Okay, do y'all see this line down here? Okay, what would this angle equal?
180.
180. Okay, so if I know this piece is 155, then how am I going to get to this remaining piece? 180 minus 155. 25. 25. Yes. Okay. All right, put this in your spiral, and then we're going to go to the mixed practice. Okay, but they give you, on number one, they want you to find the measure of angle 2, but they tell you right here, WHI. So if I look at this angle, WHI is the whole angle, and that angle equals 160. So to find angle 2, basically, I'm just adding up the adjacent angles. Angle 2 plus the 42 plus 104 equals 160. So whatever the measure of angle 2 is, plus 146 equals 160. So now you're just subtracting, and you should get 14.
Why does it say angle 1?
It should be angle 2.
Oh, sorry, it should be angle 2. Alright, on number 2 here, you need to label the givens. Angle AER is the x, so the x should be inside that angle. Then they give us angle REB. If I trace that, that is x plus 9. And they tell us AEB, that represents the whole angle, that is 75. So for a problem like this, because we have adjacent angles, we should be doing angle addition part plus part equals the whole angle. So you take the small part x plus the other part, the adjacent part x plus 9, that's going to equal to the 75. This is the equation I need to see on your paper. I will be checking for setup. Here we need to just combine like terms. We get 2x plus 9 equals 75. This one we're just solving for x.
Are you still checking Jason?
Yeah, I'll come once. I'm gonna stamp this, so I'm gonna check them all together.
I don't think it is. She said it's only one third first. Yeah, but I know which one is 1 and 2 are, but they don't. It's calculated.
Number 3. The key to number 3 is this symbol. What does this upside down T indicate? Which means what? Yeah, it's going to equal 90 degrees the intersection. So if I'm just looking at the intersection of these two lines, AD is this line here, CE. So where those two lines intersect, there's a box to indicate 90 degrees. So there's this side, this angle here, 90, this would be 90, over here is 90, over here is 90. You're going to have 4 right angles. So we're writing 2 different equations for 2 different variables. For the y, it's 2y plus 30 equals 90. And for the x over here, it's 6x plus 2 plus the 8x plus 4 equals 90. And then you're solving each one. Here, you'll get 2y equals 60. So y is 30 here. For the x's, you need to combine your like terms. So you would end up with 14x. Let me move this up. 14x plus 6 equals 90 when you combine your like terms. Now you're just solving for x. Can I what? Number 4, the keyword is bisects. It's not drawn to scale, meaning it doesn't look like it's cutting it in like evenly in half. But because it says bisects, you have to know that angle DEF is congruent, even though it doesn't look like it, to FEG. That's what it means to be not drawn to scale. It's not perfectly scaled to a bisect into 2 equal parts. Now, the measure of DEF, D to E to F, that is the 3x plus 1. I'm putting that in the interior. Then it says the measure of DEG. If I go from D to E to G, that is the whole angle. 5x plus 19. So, do we have part equals part, or do we have to double the part to equal the whole?
Double the part.
Yes, because if I have the whole measure of the angle, then I'm going to have to now do 2 times this part, which is the 3x plus 1. And now I can make it equal to 5x plus 19. You're just going to distribute, get 6x plus 2 equals 5x plus 19. You should end up getting x is 17. Then on the last problems here, there's 2 bisectors. Right here it says we have opposite rays. That's why we end up getting, if I have opposite rays, we get this line here. So we know the whole line is 180. Yes.
So 4 was x equals 17.
Yes. BD is a bisector of the whole angle EBC. So that means there's an arc here for our 2 congruent parts, because this is a bisector for the whole angle EBC. But they also tell us that BF, I meant to do a different color and go yellow, is a bisector for angle ABE. So BF here is bisecting this whole angle. Oops. So that means now we're going to do different arcings, but we're going to show these 2 congruent adjacent parts. So right off the bat, it says, what if I tell you the measure of ABF? So if I go from A to B to F, there it is 42. So we labeled it 42. They want us to find the measure of E to B to F. So if this is 42, what is the adjacent angle? It is also 42. Then they want us to know what would the measure of A to B to E?
80.
That would be 84. You just add the 2 parts together. Then on 6, if I tell you EBD is 4x plus 16, and DBC is 6x plus 4. We're trying to find EBD. We know that we have the 2 parts. We should have part equals part here. So the 4x plus 16 is equal to the 6x plus 4. You need to solve for the x. So minus the smallest of 4x's will give me 2x equals 12. So x equals 6. But then we have to plug it back in. EBD was 4 parentheses 6 plus 16.
Oh. You're barely over there.
Mhm.
Is this the kind you wanted to have?
Or-
Fold over?
Yeah. Yeah. Do you need to see it? Okay.
I don't know what it is.
Okay. Yeah.
No, I just wondered exactly what.
Yeah, it was this one.
That's why I get your word now.
Okay.
I would talk to her and find out what you really were.
Remember, for Logan, we have to multiply 3x plus 1 by 2.
Because this piece does not equal the whole thing.
No.
You also take
Because you don't, it's not part equals part. You have a part and a whole. The part will never equal the whole. The only time it equals the whole is if you double it.
Okay, so it is like the part of the thing you have to multiply.
So the mixed practice is in your spiral, but this worksheet is your homework. It correlates with the foldable. You're either going to do angle addition postulate or you're going to do bisector. Yeah, I'll stamp it actually Thursday.
Wait, so